Hello, and welcome to the second Space Weather Data Portal tutorial. Just like we did last time, let's click on Data to get started. The hope for this tutorial is for you to learn how to select a flare not based on time, like we did in week 5, but based on flare class, which we will be doing in weeks 8 and 9. To do this, go to this Display Events section and click on Solar Flare. You now see that there's red bars that pop up. These are all of the solar flares that are between X1 and X9 class. If you were assigned an X class flare, what you'll want to do is drag this bottom cursor to X1, the lowest type of X class flare, and the upper cursor up to X20 or above. Most classes go from 1 to 9, but X is the highest, and anything above X, it just continues to add numbers. We also will want to change the subset of this range. So up here you see this subset range bar. This might, when you first come in, be expanded or look something like this. When you move the subset bar, you see right here, this date will change. We want the subset range to show the dates that the GOES 15 satellite was in orbit and collecting data. And that is from March 2010 right here, through December 2018. Now these red marks are all of the X-class flares that occurred during this time. Let's try to find one to look at. I can drag this yellow cursor, you see here, over and go on top of one of the X-class flares. What I'm doing when I do this is I'm changing the date range. You can see that it's changing here in the selected range. Can be a little tricky sometimes. Okay, so I have this X-class flare that I'm interested in looking at highlighted. I can go down just like before and select solar, then go to the GOES 15 XRS flux 1 minute average and click on long wave. If I'd like to also display the picture of the flare, I can also include the data from the SDO and click display. Now I see quite a few flares here. Which of these is the X-class flare that I want to analyze? I have to figure out which one of these flares is an X-class flare. So let's go to our little flare classification cheat sheet. You should see this in your student guide. X-class flares are any flares that are greater than 10 to the negative 4. So if we go back to the Space Weather Data Portal, we see that this is 1, 2, 3, 4. This line here represents 1 times 10 to the negative 4. So anything greater than this line is an X-class flare. In this case, we see within this data range, there's 1, 2, 3, 4 different X-class flares. Let's zoom in on each of them and see which one would be a good one to pick to analyze. I'll start with this first one. So first thing I notice is that this flare is relatively smooth. It doesn't seem like there's another flare that is happening inside of this one. Let's also zoom in on the pre-flare data. We can see here that there's 3 or 4 potential other flares. Let's see what class they are. 1, 2, 3, 4, 5. These two are 1 times 10 to the negative 5, and according to our sheet, something between 1 times 10 to the negative 5 and 10 to the negative 4 is an M-class flare. So it looks like we have two M-class flares, 2 or 3 M-class flares, and also a C-class flare in this range beforehand. Still, right before the flare, if we zoom in even more, it's fairly smooth. It's sloping down a little bit, but maybe we could just take an average to this area. Or zooming out again, we could potentially fit this entire length and do some thresholding or finding local minima in order to not include the data from these flares. So I think that this is slightly challenging, but definitely a reasonable flare to pick. Let's look at the next flare. This is the flare right here. Zoom in. So again, this flare is relatively smooth and it doesn't look like there's a second flare inside of this flare. I'll show you an example of that in a little bit later in this tutorial. We can zoom in. Zoom in on the pre-flare background. So there's sort of a bump that's leading up to it, but you know, this is probably a good region to just be able to take a straight average of the pre-flare data. There are a few other flares to deal with. This is a 1, 2, 3, 4, 5, 10 times 1 times 10 to the negative 5. So this is an M-class flare that happens beforehand. But it seems reasonable to be able to threshold over that or find a region that's relatively flat to take an average. So again, slightly challenging, but not something that I think will trip too many people up. And it's very similar to the September 10th flare that we just looked at. Let's look at the third one. Zoom in on the pre-flare. This has a really nice spot. There's not a huge flare, maybe a C-class flare here. A nice spot to average over. This would be a decent flare to choose. If we look at the flare itself, it doesn't look like there's any other flares that are happening. So this also seems like a reasonable flare to choose. And let's look at the last one. Again, no other flares that are occurring. If we zoom in on the pre-flare data, extremely smooth. This would be very easy to analyze and a really nice flare to choose if you don't feel as comfortable with programming or data analysis. Maybe this is your first time trying it and you want something that is going to be relatively easy to analyze. So those are a few examples. Let's say you were assigned a M-class flare. Well, you'd go back to this area, and instead of having x1 to the maximum, you'd go from M1 to M9. Now you can see that there's a lot more M-class flares than there were X-class flares. Again, remember to reset your subset range to be over the time that the GOES 15 satellite was in orbit and collecting data. That's March 2010 to December 2018. Let's pick an M-class flare, maybe around this group here that occurred in 2015, and display the data. Wow, there's a lot of flares that are happening here. And you notice that there's some gappy data as well, which occurs occasionally. So which of these are an M-class flare? Well, if we look at our cheat sheet, an M-class flare has a flux, or an irradiance, that's between 10 to the negative 4 and 10 to the negative 5. So if we look at this, 1, 2, 3, 4, 5, anything above this value here is going to be an M-class flare. So it looks like there are 1, 2, 3, 4, 5, 6, 7 M-class flares that occur in this time period. Let's zoom in on a few to try to pick one that we think would be best. this is the last M-class flare to occur. So if we look at this, we see that there aren't two flares that are occurring at the same time, which is good. We don't want to do that, or look at a flare that has that, because you won't be able to distinguish between the two energies. Let's now zoom in on the pre-flare. You see that there maybe is some other flare, some noise that's happening here and here, but it is fairly straightforward without too much noise. This would be a fairly simple flare to pick. Let's look at some of the others. Let's look at the first one. This one here is a type of flare that we should probably avoid. You see that there's actually two flares that might have occurred back to back, and when they do, we can't differentiate the energy contribution from one from the other. So this is one that we might want to skip over. Let's look at the next one. This M-class flare looks promising, except that it has a huge gap in data. This occurs occasionally for a variety of reasons. If you see this, you should skip over it and not analyze that flare. Let's look at this next one. This one doesn't seem to have a double flare, although there is a big bump of noise or another flare that is possibly occurring here at the tail end. But doing this baseline correction is pretty tricky, since there is another set of flares that happen right beforehand. This would be something that, let's zoom in on the pre-flare. You could maybe try to figure out using some sort of fit or an average of just this smaller section around here. But this is definitely a much more tricky analysis, and I think that you would want to feel really confident about your coding skills and ability with data analysis before choosing a flare that looks like this. So if I was choosing a flare, I would probably pick this one. Now let's look at some C-class flares. So I'm going to go back to select. If you were assigned a C-class flare, you're going to want to set these cursors between C9 and C1. There's a lot of C-class flares. Let's look at a flare that happened more recently, in 2018. So again, a lot of flares occurred during this time, but which ones are C-class? Again, turn to our cheat sheet. C-class flares have a peak flux or peak irradiance of 10 to the negative, between 10 to the negative 6 and 10 to the negative 5. If we count here, 1, 2, 3, 4, 5, 6. So anything above sort of halfway between 0 and 2 times 10 to the negative 6, or 1 times 10 to the negative 6 right here, is going to be a C-class flare. It looks like we have probably 1 or 2, maybe 3 C-class flares during this time period. Let's zoom in on the largest one, this first one. So as we can see, this has a definite second flare that's happening in the tail and potentially another flare that's happening in the beginning. So this is, unless you have a lot of coding experience and a lot of data analysis experience, I would avoid choosing a flare like this. And if you do have a lot of data analysis and coding experience, you might want to choose an easier flare and do that one first. And then if you get done quickly, you can push yourself and try a flare like this. You can analyze it by potentially fitting some function to this, or using some spline fit to sort of try to reverse engineer the contributions of a flare, of a smaller flare that occurred beforehand. Let's look at this next one. This potentially has another contribution. There's a little, if we zoom in at the top, there's sort of a flat top that's happening, which maybe says that there's two flares that occurred at once. But it might just be the shape of this flare as well. It's hard to tell. I'd say that this is a fine flare to analyze. If you zoom in on the pre-flare data, it looks really noisy and not flat at all. But actually, when you look at the y-axis, this is so small. This is all noise. It's actually, even though because the axis is so small, it looks like it varies a lot, but really it's very flat and will be quite simple to analyze. Is you can just take the average through this noisy data. So this would be a decent flare to analyze. Let's look at the last one. This flare also has maybe another kink or something that happens here, but this would be pretty, if you have the coding and data analysis skills, would be pretty easy to fit over, to do some sort of, even a linear fit or a polynomial fit or some spline, to ignore the contributions of this second smaller flare that occurred. If we look at the pre-flare data, some noise, but again, really quite small, easy to sort of fit a average across this, or maybe just look at the minimas and take the average of the minimas. I will point out there is another gap in the data here, so you definitely don't want, if you need to go beyond this in order to do the pre-flare analysis, you don't want to pick data that has a gap like that. Okay, so once you decide on the flare that you want to analyze, let's say I was assigned a C-class flare and I want to analyze this flare, I'm going to take a decent amount of pre-flare data and I'm going to take a decent amount of post data, so that I have the data for all of this region to help with the analysis. Then I'm going to also make note of the approximate peak irradiance of the flare. So in this case, the approximate peak irradiance, if I scroll over, you can look at the number is up top here. When I scroll over, it's going to be 4.6 times 10 to the 1, 2, 3, 4, 5, 6. 4.6 times 10 to the negative 6. So I'm going to want to record that. I'm also going to want to record the peak date and time. You can see again in the top left area, the day is 2018 02/10, so this is February 10th 2018, and the time is 13:21:00 UTC. So I'll want to record that information. Then I can go and download the data. Remember to select zoomed in range because we just want the range that we zoomed in on. We want our file to be in CSV format, and we want our time to be in ISO units. And then click download. Once you download the data, you'll be ready to analyze it in your Colab notebook during week 8 and 9. One other fun thing that you might want to do is look at, you're going to want to discuss what sort of environment was this flare happening in. Was it at a near solar maximum or a solar minimum? Were there lots of flares around it? Was there anything that you noticed, for example, this flare? Well, it's good to point out maybe that it had sort of a flat top, that you're not sure if this was contributions from 2 flares or 1, or if there's a small flare that occurred here. Anything that you notice about your flare, make sure to record that in the markdown file of your Colab notebook. This flare, a C-class flare, probably won't have that much information on it online, but most of the X-class flares and some of the M-class flares, it might have information online about when it occurred and how it affected the solar weather either here on Earth or maybe on other planets. So definitely Google your flares and try to figure out some more cool information about them. Thank you for listening. That's the end of the Space Weather Data Portal Tutorial 2.